Hello everyone. In this video, we are going to discuss about what is stack, what are the operations of the stack, and what are the stack applications. Stack is a ordered collection of elements where insertions and deletions are performed from the same end. Let me take one example. Assume that this is a stack whose size is 3. This is a stack whose size is 3. This is first one, second one, and this is the third one. So insertions are performed from the top end, and in the same way, deletions will be performed from the top end. Okay, stack is a ordered collection of elements where insertions and deletions are performed from the same end, which is called as top end, which is called as top end. Here, the size of the stack is 3. So maximum, how many elements we can insert? We can insert maximum 3 elements. Let me write the indexes. The first index is 0 index. The next one is 1, index 1. And the next one is index 2. Assume that I'm inserting the elements like this. Okay, first I inserted 10. I inserted 10. Next, I inserted 20. Next, I inserted 30. I inserted 30. First, I inserted 10. Second, I inserted 20. Third, I inserted 30. When I'm trying to remove it, which element we are going to remove it? The most recently added element. So what is that element? 30. 30 will be removed. 30 will be removed. Next, 20 will be removed. 20 will be removed. The next one, 10 will be removed. 10 will be removed. So here we can say that stack follows a order called as LIFO. That is last in, first out. That means the last inserted element will be removed first. Or can I say like this, philo? That is first in, last out. That is the first inserted element will be removed last. Now let's see what are the operations we can perform. First one is empty, is empty, is full, push, pop, peek. Next one is display. Next one is display. Let's come to the is empty function. What does it do? Is empty will check whether the stack is empty or not. Whether the stack is empty or not. If the stack is empty, if the stack is empty, it will return true. Otherwise, it will return false. Let's come to here. So initially, the top value, let me take it as top equals to -1. Initially, the top value is -1. Okay. So whenever the top equal to -1, it indicates that the stack is empty. Okay. Let me write this thing. If top equal to -1, if top equal to -1, what it will returns? Returns true. It will returns true. Otherwise, it returns false. Otherwise, it will return false. Right. Next one is full. When it will be full? Is full. Is full. Let's come to this example. Initially, the top equal to -1. I want to insert an element into the stack. So first, what I want to do, I want to increment the top value by 1. -1 plus 1. Okay, -1 plus 1, how much? That is 0. -1 plus 1 is 0. So the element should be inserted at the 0th index. So let me insert 10. 10 as inserted. I want to insert one more element. I want to insert one more element. So what I want to do, I want to increment this value. 0 plus 1, how much? That is 1. At the first index, we have to insert the value. Let me insert 20. Okay, now I want to insert one more element. So what we want to do? Again, we want to increment the value. Again, I want to increment the value. 1 plus 1, that is 2. At the second index, let me insert 30. 30. Now I want to insert one more element. I want to insert one more element. That is, if we increment it, 2 plus 1, how much? 3. Do you have the third index? No, we have the second index only. Now, in this diagram, can I say stack is full? Yes, stack is full. When the top value reaches to size minus 1, okay, top equals to 2, okay, here, see here, if top equals to, okay, size minus 1, top equal to size minus 1, what is the meaning of it? What is the meaning of it? Top value, how much is the top value? Top equal to 2. If 2 equal to size, how much is the size? 3. 3 minus 1, which is equivalent to 2. Okay, 2 equal to 2, that means it indicates that the stack is full. Okay, that means here I want to tell you that whenever before inserting an element, we have to check whether the stack is full or not. If the stack is full, we cannot insert the element, otherwise we can insert the element. Now, is full. When we will say is full, if top value reaches to size minus 1, okay, let me write it. If top equal to size minus 1, return true. Otherwise, Otherwise, what it will return? Return false. Otherwise, it will return false. Next function. What is the next function? Push. Next one is push. What is mean by push? Inserting an element into the stack is called as push. When can't we insert the element? When can't we insert the element? If it is full. If it is full, we cannot insert it. Okay. Now we are calling this function. Which function we are calling? Call is full. Call is full function. Okay. If it is true, if it is true, what we have to do? Print the message that what is the message to be printed? Stack is full. Are you getting or not? If the we are calling is full function. If it is true, print the message that stack is full. Otherwise, what we are doing? Increment the top value by 1. Otherwise, increment the top value by 1. Top value by 1. Insert the element at stack of where? Stack of top. Okay. Otherwise, increment the top value by 1 and insert the element at stack of top. Right. The next function. What is the next function? The next one is pop. The next one is pop. When can't we pop the element? If the stack is empty. If the stack is empty, can we remove? Pop means removing the element from the stack. When can't we perform the pop operation? If the stack is empty. Okay. So call is empty. Call is empty function. If it is true, if it is true, what we have to do? Print the message. Print the message that stack is empty. Here the stack is empty. Otherwise, remove element at where we have to remove the element. We have to remove the element at stack of top. Stack of top. We have to remove the element at the stack of top and decrement the top value by 1. Decrement the top value by 1. See here. Here I want to remove it. Okay, where is the top? Top equals to 2. Here the top equals to 2. First, what we are doing? We are removing the element. Which element we are removing? Top value we are removing. Okay. Next, decrement the top value by 1. 2 minus 1, that is 1. 2 minus 1, that is 1. Now the top value is 1. Now the top value is 1. Pop. Next one is peak. Next one is peak. So peak means just it will return the topmost element. One of the interview question is what is the difference between pop and peak? Pop will remove the topmost element. The peak will just print that topmost element. It won't remove from the top. Okay. Here also same thing. Call is empty. If it is true, print the message that stack is empty. Stack is empty. Okay. Peak. Before peaking, we are calling. Before peak, we are calling is empty function. If it is true, print the message that stack is empty. Otherwise, print the value at stack of top. Stack of top. Next function. What is the next function? The next one is display. Display will print the messages, print the values that are presented in the stack. So if the stack is empty, can we print any values? No. Okay. So same thing I'm writing here. That is before displaying, we are calling is empty. If it is true, print the message that stack is empty. Otherwise, print the values, print the values from where we have to print stack of 0 to stack of top. From stack of 0 to stack of top, we want to. Okay, see here. What it mean? If we call this display function, what we are doing, the stack value is starting from 0. Stack of 0 to where stack of top. Okay, stack of top means top of 1. So from here to here it will print. So what it will print? First it will print 10, next it will print 20. So these are the operations that we can perform on the stack. Okay, let's come to the stack applications. The first application is in function calls. In function calls, we uses stack, and in the recursion also, in recursion calls also we uses. Okay, let's come to the, let me give one example on this function calls. Class demo, just save it, desktop, NRCM, fourth year, demo.java. Right, I saved it. Let me write the main method, public static void main string args. Right, so here I am writing one method, static void wish, which is not taking any parameter, system dot out dot println of hello hello. So here I'm calling this wish method and hello space how are you. Now let's save this. Let me compile and run it. Javac demo.java, compile successfully. Let me run it. Java demo. One second, it's taking something else. Sorry. Let me check it where I saved it. Oh, here, fourth year. I saved here. Javac demo.java. Hello, how are you as printed. Now let's see here how the stack is using. We know that execution of a program begins from main method onwards. This is the method call. Whenever the controller encounters a method call, it will store the address of the next statement inside the stack. Let's say the address of this statement is 100. This 100 will be stored inside the stack. Okay, let me say initially the stack is empty. Stack is empty. So this 100 will be stored inside the stack. Before before going to the function definition, it will store the address of the next statement inside the stack. Now the controller will jumps to the function definition and it will execute it. That is, hello will be printed. After completion of execution of this method definition, now the controller will jumps to the stack and it will pick up the topmost element. How much is the topmost element? The topmost element is 100. Now it understand that it has understand that it has to continue its execution from from the address 100, from the address 100, from the address 100. Okay, now let me give one more example. Static void by message I am printing. Okay, from the static method I'm calling this by. Now let's once compile and run it. So hello, bye, how are you? Okay, here let me tell you how it is executing. As usual, the execution starts from main method onwards. Wish method. Okay, what we are doing, we are calling the wish method. Before going to the method definition, what happens? It will store the address of the next statement. How much is the address I have taken? 100. Okay, this 100 will be stored inside the stack. Initially, the stack is empty. Okay, let me store 100 here. 100 as stored. Now the controller now the controller came to wish method. Okay. Now hello has printed. First hello has printed. Next one is by. Next one is by. Before going to the method definition, it will store the address of the next statement. How much is the address of the next statement? 200. Okay. This 200 will be stored inside the stack. Okay. So here, how much value we are, sorry, how much value we are storing? 200 we are storing. Okay. Now the controller will go to here, by message will be printed. Afterwards, it will come back to the stack. It will come back to the stack and it will pick up the topmost element. How much is the topmost element? The topmost element is 200. Now it has understand that it has to continue its execution from 200. 200, what does it represent? It represents the closing of a wish method. Now again what happens? The wish method has completed. It doesn't know from where it has to continue its execution. Again it will go to the stack and it will remove the topmost element. Now the topmost element is 100. Now it will continue its execution from 100 memory location. How are you? So what will be the output? Hello, bye, how are you? You can observe here. Hello, bye, how are you?